Hello guys and welcome to this video on index laws 1 and 2. My name's Darren, Maths Guru. Really good to see you. Thank you very much for watching. Short introduction. All I want you to do, if you can, is subscribe to my YouTube channel. If you're watching it on mathsguru.com, head over to YouTube and subscribe, or maybe click the little thing in the corner. It doesn't mean anything to you. It does mean a world to me if you subscribe. Why? It just lets me know that you're watching. Okay? Whew, right, I love making these videos, but I'd love for people to know that they're out there. So also spread the word. Now, what are we dealing with today? How to use index law 1 and index law 2. And we're going to recap a little bit because in a previous video, you have watched the previous video because that was the foundation for the rest of the work. Okay, no, pause, go back and watch it. Oh, wait. All right, okay then, I'll continue. So with this video here, what are we going to do? We are going to try and build on the work we had before. And we said that we can actually write all these long strings, x times x times x times x times x times x times x, in an easier way. And that's by using power notation or index notation or exponent form, depending on which area of the world you live in and whether Barry has had his influence on you. All right, I call them floaty numbers because they're numbers what float. All right, now there are rules that make life easier for us, and that's what this video is going to be talking about. And as I say here, isn't life filled with rules? So many rules. You've got to have your shirt tucked in. You've got to have your hair to a certain length of your collar. Oi, why do we have all of these rules? It's just the way we work, yeah? Because later on, when you got some sort of a job, unless you run your own business where you can decide what you're going to wear, I very much doubt you're going to be able to walk around with your shirt untucked. So maybe we're preparing you for a bigger thing here. You think of it as horrible, horrible teachers, and I think of it as, well, we're trying to prepare you. Anyway, rant over. Let's go on. Now, we're going to meet all 5 of these rules over the course of this video, all right? Or this series of videos. Not this one video, it'd be too long. All right, but we're going to look at the first 2 rules first. So rule number 1, what I'm going to do for each of my videos is write the formal definition first. So that's the formal definition. A to the floaty m times a to the floaty n is equal to a to the floaty m plus n. That's the formula. That's what an exam may give you to try and trick you. But I want you to look through this and go, well, hold on a moment, is there an easier way of doing this? Yes, there certainly is. So example number 1 says to simplify x squared times x cubed. Now, at the moment, the only way I know how to do this, building on my previous video, is to write that out in expanded form. So that would be x times x, that's x squared, times x times x times x, which is, hold on a moment. When I write it out like that, I've got my x times x times x times x times x. Well, that's just the expanded form of something else, isn't it? Because all the letters are the same. They're multiplied together. So I can write that as x to the power of floaty 5. Interesting. This one here, x to the power of 5 times x to the power of 12. There is no way I'm going to do that, but let's try something else. All right, we'll come back to that one. X to the floaty 4 times x to the floaty 3 then. All right, so x to the floaty 4 is 1, 2, 3, 4 times 1, 2, hold on a minute again. They're all the same letter. They've all got times in between them. So I can write that simpler. I've got 1, 2, 3, 4, 5, 6, 7. X to the floaty. Are you seeing the trick here? All right, let's just do this simpler. Let's just do x times x squared. I've got an x times x times x, which gives me x to the floaty 3. I can see this now. And really, what this rule here is trying to say is that when the base numbers are the same, or the base letters are the same, and what we notice here, this x here and that x were the same, that x there and that x are the same, that x there and that x are the same, what we can do is add the floaty numbers. And again, if we notice, there's my m, there's my n, and it just says add the floaty numbers. So what have we got? We've got 2 plus 3 is 5, ka-ching. 4 plus 3 is 7, ka-ching. Hold on a minute. Well, there's a 2, but what number is there? Well, that elusive number, the one number that we don't have to write, 1. Yeah. So that actually is a 1, and 1 plus 2 gives me the 3, and ka-ching, there is actually rule number 1. So if we now want to simplify x to the floaty 5 times x to the floaty 12, that would become x to the floaty 17. Now this works when there is a multiply sign in between it. All right, so when you multiply floaty powers, add them together, so long as the base is the same. So writing that in real English, because that's really good, all right, it's trying to tell us that when the bases are the same, so important. So many people will get things like x squared times y cubed and write silly things like xy to the floaty 5. No, 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 no. First things first, those bases have to be the same. So in that situation, we cannot do this. That makes absolutely no sense mathematically, yes? So when the bases are the same and they are multiplied together, we simply add the indices. Now these notes are all downloadable. You can download them from mathsguru.com, copy them into your summary books or just cut them up. They're there for you to help, right? We can also see that writing the above formula with the base letter A are the same. Now again, we could write that as x to the power of m times x to the power of n is equal to x to the power of m plus n. Doesn't matter what letter we use here. For some reason, A seems to be the letter of choice, but when we are multiplying two indices things together, we simply add the indices. Now, as I say here, there are lots of errors that people can make. People make silly mistakes all the time in these, all right? And two of them are shown there. So 2 to the floaty 3 times 2 to the floaty 5. Right? Now, are the bases the same? Yes. And what you noticed from the formula was that base should stay the same. So if there's a 2 there, there's a 2 there, then the base stays as a 2. You simply add those two together to give me 8. What lots of people do, can you see what they've done here? They've actually multiplied the two 2's together as well. You don't need to do that. That's not the rules. What about this one? 2 to the power of 3 times 2 to the floaty 5 gives me 2 to the floaty 15. Can you see what they've done there? Well, the bases are the same, but they've multiplied the powers. They didn't add them together. Right, so look for the tricks. Write some examples in your summary book. That might be useful. All right, so let's do some quick examples just to test. You can pause the video here if you want to and have a go. And thank you to Cambridge for allowing me to use their examples. Just stunning. So happy. Thank you very much. So simplify giving your answer in index form. What have we got here? 3 to the floaty 6 times 3 to the floaty 4. All right, so are the bases the same? Yep. So we just copy the 3 down. They're multiplied together, and so we add the bases together, add the powers together, 3 to the floaty 10. Hold on a moment, Maths Guru, you said this stuff was hard. No, I didn't. No, I didn't. Let's do the next one. 7 to the floaty 9 times 7 to the floaty 4. Are the bases the same? Oh, yes, stays the same. They're multiplied, so we add the powers, 7 to the floaty 13. You got there before me, didn't you? Now we're going to move on to rule 2, and I'm going to give you the basics first, right? The difficult way first, but I wonder if now, having got the information from the previous, whether you can start to decode this and see what it's saying. So the formal rule says a to the floaty m divided by a to the floaty n is a to the floaty m minus m. Do you notice the difference? Well, here we now have a divide sign. The bases are still the same, but what do we seem to be doing to the powers? Now, I'm going to show you this the long way so that you know why this is happening, and then I will show you the shortcut, as it were. So if we now have b to the floaty 5 divided by b to the floaty 3. Now, whenever they write a divide sign like that, it's always a trick. Generally speaking, it's a trick. But in this situation, that means b times b times b times b times b divided by b times b times b. Now again, when we have fractions, what we tend to do is look at are all the tops multiplied together and are all the bottoms multiplied together? Because if they are, we can start cancelling things through. And what we notice is, yep, there's a load of b's on the top all times together and a load of b's on the bottom. So when we have something on the top and something on the bottom, they effectively become 1 because b divided by b is the same as 1 divided by 1. b divided by b, 1 divided by 1. b divided by b, 1 divided by 1. And there we go. Now I've got no more b's on the top and bottom that can sort of cancel each other out. So what do I now left? Well, we know that multiplying fractions together or multiplying things together is really easy. So if we now look at the top, we've got 1 times 1 times 1. Well, that's 1 times b times b. So that now becomes b to the floaty 2 divided by 1 times 1 times 1, which is 1. And we know that anything divided by itself is equal anything divided by 1 is equal to whatever the thing is. Got to think a better way to say that. So what we notice is that b to the floaty 5 divided by b to the floaty 3 is b to the floaty 2. Hold on a minute, that's that rule. That was a 5, that was a 3, and what do we notice? We've subtracted them to become a 2. The whole point of this part of the video, though, is to realize that when we are dividing stuff, we are literally dividing them, okay? So you can write them longhand in expanded notation if you need to. Right, so let's see, fractions again. Remember, when all the pronumerals and or numbers connected by multiplication signs on the top and the bottom, we can cancel things down. Right, so anything divided by itself is 1. So we can look at the following example. Let's do it the long way again. So what do we have here? We have x to the floaty 7 divided by x to the floaty 3. And a question I'm going to ask for later on is, what if I was to have these the other way around? Wonder what would happen. So we got 1, 2, 3, 4, 5, 6, 7. I bet you can get to the answer before I can even finish writing all these x's out. X times x times x. Let's start cancelling them through. Are they all multiplied together on the top? Yep. Are they all multiplied together on the bottom? Yep. Can I cancel? Yes, so long as there is a letter on the top and the bottom that are the same. So that x becomes a 1 and that x becomes a 1. That becomes a 1 and a 1. 1 and a 1. And I really would suggest writing those 1s. Later on it's going to make life so much easier. Right, what do we get left with then? So write an equal sign. We've got 1 times 1 times 1 on the top. It's 1. And x times x times x times x, which we can now write as x to the floaty 4, divided by 1 times 1 times 1 times 1, which is 1. And once again, that becomes x to the floaty 4. And has the rule worked? Well, our bases are the same. So the x is there, the x is there, and the x stays there. But 7 minus 3 gives us our 4. So that is the shortcut. When we divide two index terms, we're actually subtracting the indices, so long as the base numbers are the same. Now, as I said a moment ago, what happens if we swap the numbers? Simply expand, simplify the following. Now, when I do this longhand, 3, 4, 5, divided by 1, 2, 3, 4, 5, 6, and 7. When we start cancelling them down, we've got a 1 there, and 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 then we're done. We have no more x's on the top that can cancel with an x on the bottom. And when we simplify this, what do we have? 1, 2, 3, 4, 5. 1 times 1 times 1 times 1 times 1 is still 1. Divided by 1 times 1 times 1 times 1 times 1, 1. X times x give me x squared. Aha! Now we have 1 on x squared. And sadly, a lot of people go, well, we can just write that as x squared, can't we? No, remember, that's only if we divide the x squared by 1. This has the 1 on the top and the x squared on the bottom. So we can see that that becomes 1 on x squared. But what happens if we were to use our index rule? Well, let's have a look. We have x to the floaty 5 divided by x to the floaty 7. X to the floaty 5 divided by x to the floaty 7. Well, the bases are the same, so we copy the x down. We've got to divide, so I'm going to take away my floaty numbers. 5, that becomes minus 2. And first things first, we can have negative numbers. But what we notice is that they must be the same. So we now know that 1 on x squared becomes equal to x to the floaty minus 2. Tricky! Now, I'll deal more about that one in a later video, but it's important to know that actually negative powers have a meaning, and a really important meaning at that, okay? So this is really important and used in a lot of mathematics, the 0 power rule. Anything to the power of 0 is 1. And let's just work out why. So if we take x to the power of 5 and divide it by x to the power of 5, if we use the index rule, what do we get? We get x and x, they're the same. We divide, so we subtract the power. So that becomes x to the power of 0. But we know that anything divided by itself, and we notice there that if I write it as a division, or even if I don't write it as a division, what do we see? We see they are the same. So x to the floaty, for anything divided by itself is actually 1. Hold on a moment. So again, that would suggest that because they are the same, x to the floaty 0 is equal to 1. Well, let's try a different example. Let's try a to the floaty 7 divided by a to the floaty 7. Using our index rules, the bases are the same, take away the powers. But we know that anything divided by itself is also equal to 1. So in that situation, we've got x to the floaty 0 is 1, a to the floaty 0 is 1. And that's where we're going to go. You can do this as many times as you like. You can even use numbers. We could say 2 to the floaty 4 divided by 2 to the floaty 4. Using index notation, that becomes 2 to the floaty 0. But we know that anything divided by itself is equal to 1. So anything to the power of 0 is 1. And we use this in exams over and over again. Right now, again, don't get confused, because here, when we have 4x squared all to the floaty 0, you've got to ask, who does that floaty 0 belong to? And if you notice here, we have a set of brackets. So that means that everything inside of here is to the floaty 0. And in which case, that there would equal 1. That would be very different from example if I had 4x to the floaty 0. Because who does the floaty 0 belong to there? Well, there are no brackets. So in this situation, that only belongs to the x. So we would know that this thing here is equal to 1. So that there would be the same as 4 times 1, which would actually be 4. See how tricky this can get? But just ask yourself the question, who does the 0 belong to? So let's have a look at some quick examples again. Simplify each of the following using the first index law. All right, so this is law 1. So what do we have? X to the floaty 4 times x to the floaty 5. Now we're timesing in this situation, so times, we're going to add them. So the bases are the same, add those together, gives me x to the floaty 9. Tick, thank you very much. Can you beat me to the next one? All right, well, what do we got here? X to the floaty 3, y to the floaty 4 times x squared y. Now this is a bit of a trick. Why? Because between all of those are time signs. So that's the same as x cubed times y to the floaty 4 times x squared times y. Now, are they all times together? They flipping are. So what we now can do is, well, I'm going to actually do the rules on my x's first and then my y's. Now, just to make it simple, I'm going to rearrange things. So x cubed times x squared, y4 times y. Now, some people like rearranging them because it makes it easier, because I can now deal with this term here. So x to the floaty 5 times y to the floaty 4, remember, if it doesn't have a floating number, it's a 1, times y to the floaty 5, and in which case we could write that as x to the floaty 5, y to the floaty 5, and there is my correct answer. Woo! Next one, running out of space. What do we have here? 3m to the floaty 4 times 2m to the floaty 5. Now again, I'm going to write that as 3 times 2 times m to the floaty 4 times m to the floaty 5. And you can do that when they're all multiplied together, and between the 3 and the m to the floaty 4, there is a times. You can rearrange it, and I always rearrange it to put my numbers first. So 3 times 2 I can write as 6, and there we go, there's my rule 1. So they're both the same letter, so that becomes an m, and 4 plus 5 becomes 9. Did you get all those right? Oh, of course you did, you're guns at this. Let's do some more practice now for rule 2. All right, so what we got here, x to the floaty 10 divided by x squared. Now we could write this longhand, but I'm not going to write this longhand, thank you very much, because I know that I've got index notation. The bases are the same. I've got to divide 10 and 2, take those away, gives me x to the floaty 8. I know you got there before. Now the next one is a bit of a trick. 8, a to the power of 6, b to the power of 3, all divided by 12, a to the floaty 2, b to the floaty 2. Now, what can we do here? Well, there's lots of different ways of doing this. Now, when the fraction is all times on the top and times on the bottom, we can actually write it in a different way. We can actually split this up to become 8 on 12 times a to the 6 on a squared times b cubed divided by b squared. And again, if you're not sure why, if you multiply those three together, you will go back to exactly. Now this only works when there's times on the top and times on the bottom. And what can I do now? I can actually cancel down, because we know that 4s go into 8 twice and 4s go into 12 3 times. So I've done my numbers first. Now I've got this here, a to the floaty 6 divided by, hold on, I take the powers away, don't I? Absolutely, you can take those away. So we now know that that becomes 2 on 3 times, this is going to be a to the floaty 4, because I'm going to do 6 minus 2, which gives me the 4. And I've got this one here, which is going to be times b to the floaty 3. 3 minus 2 is 1, so b to the floaty 1. Now to simplify this all together, we just times it or squidge it all back. So we have 2/3 a to the floaty 4 and b. That is certainly one way of being able to do it. There are other ways of doing it. Now you could write that out longhand and then cancel top and bottom, and that's going to certainly be a method I'm going to use later. But another way of thinking about this is to look at how many A's you have on the top and how many A's you've got on the bottom, how many B's you've got on the top, how many B's you've got on the bottom, and cancel them. So first thing first, I always deal with the numbers, and again that becomes 2 and 3 because they get divided by 4. Now I've got 6 A's on the top and I've got 2 A's on the bottom. So those 2 A's are going to cancel out with 2 of them on the top and just leave a 4. Yeah? Now if you don't believe me, write it out longhand. Write it as 8 times A 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 times B times B times B, and then the bottom as well, and start cancelling them out. And you'll notice that the 2 A's on the bottom all become 1s, and the 2 of them on the top will become 1s as well, leaving 4 of them left. Likewise, we've got 3 B's on the top and 2 B's on the bottom. So 2 of those there are going to cancel and become 1. And we're going to take away 2 from there to give me 1. And what do we end up with? Exactly the same. 2 a to the floaty 4 b all divided by 3. And again, these 2 here are exactly the same. And now we look at what examples where the laws are combined. What does that mean? We're going to use both example law 1 and law 2. So we've got here x squared times x to the floaty 3 divided by, now in that situation that is all divided by x to the floaty 4. Now I can't do anything at the moment because I'm going to simplify. And I know I can simplify the top first. So I'm going to simplify the top, and that's going to become x to the floaty 5 divided by x to the floaty 4. And again, we can take away powers, or we can say, well, 4 of those x's on the bottom are going to cancel with 4 of those x's on the top, which is just going to leave me with x to the floaty 1. Do I need to write the floaty 1? Not really, just write x. What about this one? Oh, this looks complicated. 2 a cubed b times 8 a squared b cubed, all divided by 4 a to the 4 b squared. Right, so I'm going to simplify the top first. How are we going to do that? Well, they're all times together. So I'm going to do my 2 times my 8, which gives me 16. Then I'm going to look at all my a's on the top. I've got a cubed times a squared, so that becomes a to the floaty 5. I've got b to the floaty 1 and a b to the floaty 3. That becomes b to the floaty 4, divided by 4, a to the floaty 4, b to the floaty 2. Now, have you noticed how that's now going to make my life a little bit easier? Because I'm going to deal with my numbers first. 4's into there go 4 times, and 4's into there go once. I've got 5 A's on the top, 4 A's on the bottom, so 4 of those A's there are going to cancel completely, and 4 of those are going to cancel to leave me just 1 A left. I've got 4 B's on the top and 2 B's on the bottom, so 2 of those B's are going to disappear and become 1, and 2 of those are going to become 1 to leave me with 2. So let's now write this out in a simpler form. We've got 4 times a to the power of 1, b to the power of 2. So we've got the 4ab squared divided by 1 times 1 times 1, which gives me 1. And so in which case my answer becomes 4ab squared. Now there's a lot of work here, isn't there? Yeah, but you will be guns at this with lots and lots of practice, I promise you. And there we go, guys, that's the end of this video. Thank you very much for watching. Hopefully it has been helpful. More videos to come. Please stay tuned. If you found this useful, like, subscribe, tell your mates about my channel and maffsguru.com. Otherwise, hopefully I'll see you in another video. You take care, guys. Stay safe. See you soon.